In section 7.2, we're going to look at exponents again. So we need to remind ourselves about the rules of exponents. Well, remember the main idea behind the rules of exponents is in order to do anything, the bases have to match. And if they do, the base will stay the same. So first of all, bases stay the same. Only the exponent should be changing. So only the exponents change. So then what are our rules for exponents? Well, remember that when you're multiplying, what do you do to your exponents? You add. Which means, okay, what if we have a power to a power? Well, remember the parentheses in the middle should remind you that you're going to do what to those two exponents? You're going to multiply those, m times n. What if you have parentheses and an exponent on the outside? Well, what this next rule, number 3, tells you is to distribute that exponent to everything that's on the inside. Rule 4 says the same thing. If your exponent's on a fraction, distribute the exponent to everything on top and on the bottom of the fraction. Rule 5 says, well, if I have anything raised to a 0 power, it will automatically equal 1. This is a special case. What about the next one? On 6, it says if we have a negative exponent, we don't want to have negative exponents in our answer, so how do we get rid of them? We drop them down to the denominator, and then the exponent becomes positive. Notice then what's left where we were is a hidden 1. That was the 1 that was hidden out in front of our term to begin with. Problem 7 says, what if your negative exponent's already on the bottom? Well, then it'll flip, but it flips up to the top, and it becomes a positive n when you flip it. So it goes up with your hidden 1, but then you can just re-hide the 1. And so it just looks like an x to the nth. What if you're dividing? Again, as long as the base matches, it will stay the same. Then you're just worried about your exponents. What do you do to your exponents when you're dividing? You subtract. Here's another one. What if you have a negative exponent on an entire fraction? That means you've got negative exponents on everything. Well, you can just make the whole thing positive by flipping the entire fraction upside down. Why are we even talking about this, though? Why are we talking about rules of exponents when we've been talking about roots? Here's the punchline. We're going to talk about this because roots can be turned into fractional exponents. So, for example, if we have an nth root, the root is, remember, what's on the outside of the root. The root will be what goes on the denominator or fractional exponent. That will be your root. Go on the bottom. So if it's a square root, that number would be a 2. If it's a cube root, it would be a 3. Now, notice you do end up with a 1 on top. The question is why? Well, what's the exponent on the x that you're not seeing? Well, it's a hidden 1. That's why you get a 1 on top. So, let's take a look at a few examples and see what these turn into. What kind of roots? Now, they call them radicals, but roots and radicals mean the same thing. That means this fancy symbol is called a root or a radical. So let's look at this first example. We've got 26. Let's see, we've got 26 to the 1/2. So we look at the denominator to see what kind of root it is. It tells us we're going to have a 2 root, which means we have a square root of what? Whatever number we have here, which is the number 26. So we've got the square root of 26. Technically, it's to the first power, but remember, if anything's raised to the first power, we don't have to actually write that 1. So it's just the square root of 26. Now let's take a look at B. We've got 13 to the 1/7. Well, again, let's take a look at the bottom. The bottom of that fractional exponent tells us what kind of root we have. In this case, it tells us we have a 7th root of, what's our number here? 13. So we've got the 7th root of 13. Again, technically that 13 is raised to the first power, but anything raised to the first power means you don't need to write the 1. So it's just the 7th root of 13. Now let's look at C and D at the same time. Notice they look almost identical. The difference is that one has parentheses and one does not. So on one of these, the negative will be on the inside of the root, and on the other, the negative will be on the outside of the root. Well, notice the one that has the parentheses around the negative is going to be the one that has the negative on the inside of the, in this case, what kind of root is it? It's a 4th root. So I've got a 4th root of, again, the negative 81 is inside the parentheses. So the negative 81 will be inside the 4th root. Okay, on C, notice there are no parentheses. So that negative will be on the outside of our, in that one, again, it's a 4, so it's a 4th root. But only because there are no parentheses, only the 81 will be on the inside here. So only the 81 will be on the inside of that root on C. So one of these has an answer between C and D, and one of these does not. And the answer is that C does have an answer because that negative's on the outside. It will just go on at the end. This can be simplified. And they did want us to evaluate if possible. So this will be a negative. Well, what were they asking me to find out? The 4th root of 81. What number multiplied by itself 4 times or raised to the 4th power would be 81? And that's a 3. Again, just tacking on the negative sign at the end. However, D asks, what number multiplied by itself 4 times or raised to the 4th power is a negative 81? And it's not possible. We can't have a negative inside of an even root. At least it's not possible yet. So again, we'd give the same vague answer we gave before, which is this is not a real number. Continuing along, let's look at E. Notice we do have parentheses around the negative 64. So the negative 64 will be inside of our root. The question is, what kind of root? Well, let's look at our denominator here. Well, it's a 3, which tells me I'm going to have a cube root. So this is asking what number, either cubed or multiplied by itself 3 times, will give us negative 64. This is okay to have the negative on the inside because it's an odd root. So what number multiplied by itself 3 times gives us negative 64? Well, that's a negative 4. In F, we've got a 4 on the denominator, which tells me I've got what kind of root? A 4th root. What's inside that root will be, well, the entire 1/16 is inside with the parentheses. So 1/16 will also be on the inside of our 4th root. So we've kind of done this already. So what multiplied by itself 4 times is going to give us the 1 on top? Well, that's just a 1. And on the bottom, what multiplied by itself 4 times will give us the 16? That's a 2. So that gives us the fraction 1/2. Now let's look at solving some